Okay, guys, here is the Excel for chapter 10. Um, so, chapter 10, we're talking about one sample test of hypotheses and um, what process to use, how we're going to test these things, okay? All right, so I got this problem set up for you. It's from the book. The setup is that there is a manager of a regional airport, and he's had a couple people come up to him and complain lately that there is no parking in the short-term parking lot. So he's thinking that maybe people are um, staying in the parking lot longer than the 40 minutes that they think is the average right now. Okay, so we're going to test to see if that is a possibility or not. Okay. Um, Through years of tracking this stuff, they know that the population standard deviation is 10 minutes, okay? And I have that written out for you here. All right, so population standard deviation of 10 minutes. Our our null hypothesis here is that the mean amount of time that that I would say customers, but people stay parked in the short-term parking lot is less than or equal to 40 minutes. Again, inequality, right? In the null hypothesis. Okay? Or equality in the null hypothesis, right? Our alternate hypothesis is that the mean is greater than 40 minutes, that people are staying longer than 40 minutes on average. Inequality, yeah? Not less than or equal to, greater than or equal to, is greater than, okay? And over here we have the minutes. So the manager goes out and takes a sample of people who are parked in the short-term parking lot, um, and that's what he comes up with, okay? So, um, so how would we do this? How would we do this testing on Excel? So hopefully we've had enough time in chapter 10 now. You've had it assigned to you that you've done some of these by hand, practiced a little bit, okay? Because again, just like the rest of this class, you need to know what's going on behind the numbers. The whole semester, what the whole point of what we've done is to look under the hood, right? To see how all this stuff really works, all right? And the same with this chapter 10. So, but now we're going to see how to do it in Excel, which is probably the more, let's face it, the way you do it in the real world. But again, you got to be able to explain your numbers to if somebody's going to loan you money or invest in your company, or if you have a boss that's asking for it, you got to know your numbers. All right. All right. So how are we going to do this in Excel? I'm going to go to my data analysis package. So under data, I'm going to go to data analysis, okay? If you don't have this, I'm going to show you right now how to get it, okay? So what we're going to do is we're going to go to File, okay? And we're going to go to Options. You can't see it, but I have a little timer, so I hope it's not going to mess me up. So there it goes, Options. Um, we're going to go to add-ins, okay? And we're going to go down here to manage add-ins, and we're going to leave it on Excel add-ins, all right? And we're going to press go. And we want to add the analysis tool pack right here, okay? This is something else you need to learn, optimizations with Solver, but anyway, that's not for this class. You'll probably do it in Dr. Kim's class next semester or later on. But anyway, analysis tool pack. All right, click OK, and it'll pop up data analysis. The data analysis pack will pop up right here, and it'll probably uh, insert itself in a new group called in the new analysis group if you don't have anything else right here. So we'll create a whole new group called analysis, and it'll be right here under data. Okay, and again, if you didn't get that, I go over it ad nauseum in the videos. All right, so you got to know how to do this because I'm not telling you how to do it while you're taking the exam. That's something you just have to remember. Okay. All right, so let's get back to the problem here. We have a population standard deviation. So we do know the population standard deviation, and it's 10 minutes. Okay, so that should be our big clue as to what we're going to use in the data analysis package. And I already have it highlighted here, but it's all the way down here at the bottom, and it's the z-test. But wait, this says 2 sample tests for means. What is chapter 10? It's 1 sample test, isn't it? Okay, so we have to create a dummy variable over here. Okay, and let me show you actually why. Because this is the two sample test for means. I'm going to double click it or click on it and click OK. It's asking me for input variable 1 range and variable 2 range. We only have one variable, don't we? We have to put something in here. Excel's going to make us put something in here. So we have to create a dummy variable, just a placeholder, yeah, for this, and we can get rid of it later, but we have to have it in order to make Excel run. All right, so let's close this for now, and let's create our dummy variable. Okay, so let's just call this the dummy, and I'm going to put zeros in the first couple columns. Okay, and that's all we need to do. All right, that's it. All right, so now let's go back to our data analysis pack and go down to z-test, two sample test for means at the very bottom, double click it, and now we can say variable 1 range is the variable that we need, and variable 2 range is this dummy variable. Okay, now hypothesized mean difference. All this is really asking us for is the mean that we're curious about. In our case, it's 40 minutes. Okay, so because we're saying less than or equal to 40 minutes or greater than 40 minutes, that 40 minutes is the mean that splits it up as to whether it's going to fall into the range that we need or not. It's our starting point. Okay. All right. So variable 1 variance known. So what would our variance be? If we know the population standard deviation is 10 minutes, what does that make our variance? Okay, variance, if you remember, is just standard deviation squared, isn't it? So our variable 1 variance is 100, isn't it? So we need to square this variance. I mean this standard deviation, don't we, to get our variance? Okay. Variable 2 variance, well, it's 0, but we can't put 0 in here. Excel won't allow it. So let's go ahead and put 0.00000001, something so tiny that's not going to mess us up. Okay. And that should do. Did we include labels? Yes, we did. Our alpha of 0.05. So if you remember from our classes, what is the most common alpha that we're going to use in business in particular? And it's going to be 0.05, isn't it? Remember that alpha of 0.05, so we're going to be 95% certain. Remember, that 95% of the area under the curve is where we need our answers to fall in order to, or outside it, in order to be certain that we got an answer that's satisfactory to our conditions. Okay, so 0.05 is our alpha, right? That's those areas outside that critical value, remember, in our under our normal curve. Okay. Last thing is the output range. We can put it in a new workbook, but let's just put it here. Output range is going to equal right here, N3. Okay, so it's going to output it over here. All right, so click OK, and let's see what we get. All right, so let's widen these out so we can see what we came up with. And let's break down this chart right here. First off, let's clean it up. Let's get rid of this dummy variable, okay, because we don't need that. 2 observations, right? 0.01 was our variance, and our mean was 0, so we don't need this, remember? We just put it in there as a placeholder so Excel would do it. This is a 1 sample test of means, isn't it? So let's take that 2 out of there and put 1, okay? And what else would be different about this? Mean, known variance, observations. Well, this would not be a mean difference, would it? It would be the mean. And I think that's about it. I think that's all we need to change on this, and it looks pretty good. So we got a lot of information in here, don't we? So what's our mean? 48 of this new data. But what are the odds that we would have taken a sample out in our parking lot and gotten this mean with our real world mean being 40, as we assume it is now, does that fall outside or inside the realm of possibility? Meaning, does that fall outside of our critical value or inside? So we can look at it two ways, right? We can look at it with our z-score and our critical value, or we can look at it with our z-score, can't we? And the area under the curve. Okay. So here's our variance, our observations. We have 12. Our hypothesized mean was 40. Okay, so is it reasonable, given our constraints, that 48 would fall outside of 40 and it could be just a fluke? Or does this 48 tell us, hey, this really does mean that 40 cannot be our answer? I'm 95% sure that 40 minutes is too low. Now, when I say too low, what do I mean by that? I mean that, what does this say up here in our null hypothesis? It doesn't say not equal to, does it? It says less than or equal to. So we're only concerned with that upper side of the curve, aren't we? The area under the curve on that upper side, meaning our positives up there, but also meaning that our alpha is stacked in one side of the curve. I should have pulled up a normal curve up here. But let me pause. Okay, I found a good curve online. Okay, so anyway, so this is our alpha, isn't it? 0.05. It's not split into two areas, is it? It's all front loaded up here, isn't it? Because it didn't say not equal to. If this had said not equal to, there could have been a chance that it was down here or up here. We'd have to split our alpha, right? But we're saying greater than or equal to. We're wondering about if that 48 minutes falls in here, then we're going to reject the null hypothesis, okay? All right, so our z-score is 2.77, but what is our critical value? Was this a one-tail or two-tail? Again, it's a one-tail test. That's why we're curious about the one tail. If this had not equal to, it would be a two-tailed test, wouldn't it? All right, so the z critical on a one-tail test is 1.65, isn't it? How did they know already that it's 1.65? Because it's that every time. Remember, I told you to remember that one. 95% one-tailed test is a critical value of 1.65, isn't it? Okay, a z-score of 1.65. Okay, so this is 95% of the area of the curve. This is 5%, right? So if our critical value is 1.65, what's our z-score for a z-score for a one-tailed test? Z-score right here, z 2.77. All right, so where does 2.77 fall? If this is 1.65, 2.77 is out here, isn't it? So it does fall in the area of rejection. We also know that because our critical, what am I trying to say? Our alpha is smaller than 0.05, isn't it? Okay, it's right here. And that's smaller than 0.05, isn't it? So if 0.05 is here, our alpha is way out here, so we know we're gonna reject it, aren't we? Okay, so you can do this longhand and you're going to get the same numbers if you do it correctly, or you can do it this way. But just like with everything else in Excel that we've done this year, you got to be able to read it and you got to know what it's talking about, okay? And it's a little harder to do if you just have the numbers pop out at you than if you sort of grind it out and get into the nitty-gritty of doing the problem, all right? But so long as you can explain what's going on, behind the scenes, then feel free to use this method, okay? Now, I'm limited to 15 minutes on these videos for the free version of this software, so we're going to cut it off right here, and I will come back in just a minute and show you how to do a t-test, all right? Okay, very good.